So I told you the last class that Numpy library is for array computations, that you want to perform mathematical computations on arrays. Do you understand that? You want to make calculations, mathematical calculations on arrays, that is large high dimensional numbers. That is what I mean by arrays, or single dimensional numbers. Anywhere you have collection of numbers and you want to perform calculations on them, you will need the Numpy library. Do you understand that? So anyway, you have computation in large numbers, series of numbers, and you want to perform mathematical calculations on them, you need the Numpy library. Do you understand that? So then I made mention of, we did a lot of things, creating a Numpy library. So I told you that you can create a Numpy library from a list of numbers like this. If you have a list of numbers like this, so you can use np.array using the numbers as the arguments, then you can create an arrays of numbers. Do you understand that? So this is the same numbers here, and for example, you have this is a list of numbers from 1 to 0 to 9. Then here we created the Numpy, the arrays, an array of Numpy. Do you understand that? So we created the Numpy arrays here. So what makes the advantage of this Numpy array is the same numbers of elements. It have 0 to 9, just like this. Do you understand that? It's the same numbers of items. It contains the same numbers of items, but the advantage is that you can perform numerical calculations on it. Unlike list, if you multiply list by 2, you have duplications like this. Do you understand that? You have multiplication. You don't multiply individual item. For you to perform calculations on this, you have to look through it. But for this arrays, you can perform calculations, just multiply it by 2 here. It's going to multiply everything by 2. Do you understand that?
Yes.
So that is the advantage of using arrays. Then you can also perform higher mathematical calculations on the arrays. So if we proceed on where we stop, okay, let me start from this row. So we talk about arrays, the Numpy arrays. Then in this particular class, I'm going to give you some statistical measurement in Numpy arrays, like how to calculate the mean of arrays. Do you understand that? Mean, how to calculate the maybe standard deviation, and how to calculate the minimum, maximum. So, do you get that? So if you want to calculate this, the minimum of arrays, like if you have an array like, let me say that we have an array of x. Let's create an array from this list. X1 is equal to maybe 10, 20, 30, 50, 70. This is a list array. This is a Python list. So I want to create arrays from here. I'll say np.array x1. Do you get that? So once I run this particular line of code, so I have these representations, but it's format of in array format. Are you following?
Yes, you're following.
Okay, so you have this particular representation in array format. So let me wait for that to run. Okay, I've not import my Numpy, so I have to import it again. Import Numpy as np.
As np.
So let me run it now. So you have this representation in form of arrays. So I will now say, let me call it x1 array. So it's the same list. So if you want to find the mean or the max, so let's start from the main n1 array. So if you want to find the mean, do you understand that? So you can say x1 np.mean is going to is for finding the mean. Do you understand that? So np.mean, np.mean. So you put the number you want to find at the input. Do you get that? So what you want to find is x1 array, the minimum of x1 array. I mean the average, which is the mean. So you have at 6. Do you get that? So to look for mean, np.mean is going to look for the mean. Do you get that? Of all items in the arrays, of all numbers in the array. Do you get that? So let's now move to higher dimensional arrays. If you have an higher dimensional array, like a 2-dimensional array, if you have an array like this, let's say that x2. So we have it.
Please, can you explain a little bit what the mean is?
Mean is the average of the numbers.
Yes.
Like if summation of all these numbers.
Okay.
The length, that is 10 plus 20 plus 30 plus 50 plus 70 divided by 1, 2, 3, 4, 5. Divided by 5. So that is what the mean is. So for this x, in this I want to explain how to use higher dimensional arrays. If you have an array, let me say 2-dimensional arrays, like 3 by 3 array, something like this, 10, 20, 30, so this, I'm trying to create the 2-dimensional arrays. So we have this particular array in which there it's going to have a 3 rows. Okay, let me try to create the array np.array for us to see how it's going to look like s2. So once I run this particular line of code, so can you see that we have this is a 3 by 3 arrays. So for every rows, there is 3 items, and we have 3 rows. Do you understand that? So we have 3 columns and 3 rows. So if after you want to know the shape of this array, how do you know the shape of this array? Because I mentioned it in the last class. So let me say x2 array.
That's shape.
Is dot shape. S2 array dot shape is going to give us the shape of this array. So it's in 3 by 3 array. So x2 array, this is what we have. So we want to look for the mean. So we can look for every mean, np.mean. So it's going to calculate the mean of all items. Let me try to show you the array again. S2 array. So you have something like this. So this np.mean is going to calculate the mean of all items here, just the average of all items. So but you can calculate for a particular dimension. There's an additional argument like axis. We have this axis can either be 0 or 1 because it's a 2-dimensional. So if it is 3-dimensional, it will be 0, 1, and 2. Do you understand that? So what it means is that you are calculating. Axis means that like 1. 0 means that you are calculating for all these zeros for like the mean of this, the mean of this, the mean of this. So this is going to give us 3. Do you understand that? Why 1 means that you are calculating for all.
No, I don't.
Hello?
I mean,
Okay, let me explain that.
zero means what?
Zero means that you are going through the zeros, this particular, that means I want to find the mean of this. I want to find the mean of this. I want to find the mean of that is the box axis. So y1 means that I want to find along the vertical axis. Do you understand that? So once I run this, I'm going to have 3 items.
Okay.
So it means that it has calculated the mean of this, this, and this. Then you can also calculate the mean of 1. If it is for 1, it is for the vertical axis. So it's still 3 items. Do you understand that? It means that it allows you to also calculate for a particular axis instead of getting everything as a whole. Do you understand that? So
okay, sir. When you say 1, are you trying to refer to like 20, 10, and 50?
No. Looking at this, there are 2 dimensions. Do you understand that? There are 2 dimensions. The first dimension is that, let's say that the first dimension is the x-axis. X-axis means that it's going to like this 1. And I want to calculate the mean of all these row, or 1, or 2, and row 3. Y-axis means I want to calculate the mean of column 1, column 2, column 3. That is the 2 dimension.
Okay.
So do you understand that? So 0 is box axis.
Okay, if this is 2, then how can we know 3 dimensions, sir?
And it will be 0, 1, 2, 3.
Yes, but in what direction will the third one be going? Is it like a diagonal?
No. I think there is, you can't. Okay. And we are still going to do for that, but I'm not sure we have to use 0, 1, 2, because to get this inner, I'm still going to explain to you better. I'm going to explain to you better regarding the 3 dimensions.
Okay, all right.
But look at this. For this, let's talk about the one that requires maximum. Let's do np.max. np.max will give us the maximum number. Let's talk about np.max and np.min. np.max and np.min. np.min. So you have np.max and np.min. So for example, if you want to find np.max of everything, x2.array. So it means I want to find the maximum of everything. So the maximum of everything is what? Is 50, Abby?
Yes.
So let's now find maximum along a particular direction at this equal to 0. So it means that, look at this now. We are looking for the maximum along, okay, this is for colon. This first one is for colon. The first 0 is for colon. It's now clear to us that 0 is for column. No, the first one is like finding along this first column, which is 10, 50, and 10, which is going to give you 10. Abby? The next one is going to be 20, 10, and 20, which gives us 20. And the next one is going to be 25 and 35 and 30, which is going to give us 30.
30, yes.
So if this one now is going to find along the row, so it's going to be this 30, 50, and 30. Do you understand the difference?
Yes.
So that is what I mean by first row and second. Do you understand the difference? That is what this NP gives us. It makes provision for you to do that. Do you understand that?
Okay.
Do you understand that? So if it is for main, let's talk about main. So if it is for main, what are we going to get for this? If you are going to the first direction, what are you going to get if it is